Welcome to DESI ASTRO. In this Python for Astronomy and Astrophysics tutorial using AstroPy library, our objective is to learn that how to perform circular and elliptical masking of pixel region in a FITS image. So basically this is part 3, and in which you can see here you have a original image of the stars and galaxy, and here you can see you have a masked image, and here you can see that the red elliptical aperture is being masked, and inside the mask there is no object, so this area will be excluded from the image analysis and your further photometry. So this stuff I have to do using Python coding. Alright. Well, so before starting the third tutorial, I want to let you know that you can also watch my tutorial part 1, that how to mask pixel image above a given threshold, and part 2 and part 2, in which I have teach you about that how to do rectangular masking of the pixels in the FITS image. So like these are very crucial for understanding your part 3, right? So before jumping Alright, so now come to part 3 about circular and elliptical masking of the regions on the pixel space of the FITS image. So already I have read the FITS image, okay? So in part 1 I have read the FITS image, right? So I'm not going to this coding stuff part again, right? So let's start from the creating elliptical and circular masking. So here one thing is to be noted, that I will be performing a general thing like elliptical masking, and then we can take a special case in which where both semi-major and semi-minor axes are equal for circular case. So let's do it. Okay, so first I will import a library here. So I will import a library. So I have from Photutils dot aperture import elliptical aperture, right? Import elliptical aperture, right? Now, so that this will be used to get our elliptical aperture from the Photutils library. Now I will define here ellipse parameter such as center A and B axis, right? So I can have A. So A can be my say 300, right? And B can be say 200. So these are like same major axis and same minor axis, right? And then I can have also rotation of the ellipse, right? So theta I can give it say np dot radian np dot radians, right, 30 degree, right, and then so this is the parameters. How I can now I will create here a elliptical aperture, right? So for that I will define a position. So define position, right? So I can define position or say center. So I can define my position equal to position equal to say uh, position equal to say center x and center y, right? And then I can give my here center x comma center y equal to 500, right? This much we have done. Now I will be creating elliptical aperture. So for that, type here aperture right? Aperture equal to elliptical aperture, right? And you can pass this position a, b, and theta, right? So you have position, you have a, you have same axis, then you have theta, right? So you have theta. Now you have done this stuff. Now create a mask aperture, okay? So now create a mask for elliptical region, right? So for that I will create a mask. So mask elliptical equal to, I will give a function aperture to mask, right? So I can give say method equal to center. So this is a method equal to center, right? So what is the mistake? There should be here, not there. Yeah. So see, so basically there are like other method available for like exact. So exact center and soft pixels, right? So here you can see that the aperture weight will contain value 1 for your, I mean inside your outside the circle, outside the ellipse, and 1 for inside the ellipse masking, right? Ellipse masking. Now uh, now do the aperture masking, okay? So aperture mask, right? So aperture mask equal to 10 mask to image, right? So, mask to image, and then you can give your image data, right? So it will take the shape, okay? See what it takes. So basically there's a mistake, I think. Masked. Okay, so there should be masked elliptical, okay? Now it's fine. Let's see what it takes. So mask to there should be image, right? Mask to image. Now it's fine. So and it will take your image data, right? So image data dot shape. Okay, this will take same shape as your image shape. Okay, now fine. Now I will apply the mask. Okay, so apply the mask to image data. Okay, so for that I will type here masked image, right? Masked image equal to masked image equal to np dot where, right? So this is a condition function and where your aperture mask. Okay, so your aperture mask, okay, mask equal to 0. Okay, so 0 for like your outside and 1 for inside, right? And then I can give image data. Okay, so your image data defining my first tutorial, and then I can give the value with which I want to fill the mask. Okay, so I will give here 0. You can also give 1 or 2, but I will give a 0 for time being, right? Now I will I will plot. Okay, so I will plot the masked image. Okay, so for that I can plot here PART dot image show, right? And I can give here image data, right? So image data, or maybe you can directly go to the masked image. So masked image, right? And type here PART dot show, and also you can give here a PART dot figure for a new figure, PART dot figure, right? Now run it. So okay, so take this scale image on the log scale. Okay, log norm. So type here norm equal to log norm, right? And see. So see here is aperture. Okay, so what I will do, I will reduce the size of this aperture, right? So make it 30, 20. Now run the code. Okay, so 500 maybe. Yeah, maybe you can make the center. Okay, so change the center. Make it 200. 200. Now run the code. Okay, so here you can see that mask aperture, but I will try to make it more bigger. So make it 200 or 150. Okay, so here you can see that it is a mask. Okay, a mask image. So here you can see that you have 0 values inside this aperture, right? And you have a value of the pixel outside this aperture. Okay, So you can also produce a aperture plot. So aperture aperture dot plot, you can give it say color equal to red, and you can give a line width equal to 3, right? So here you can see that you have aperture, right? And see, so you have, I mean, everything outside the aperture is not mask and inside is mask. Okay, you can also reverse. Okay, so just go here, just go to this line. Okay, so make it 1. Okay, so if you make it here 1, see what will change. So this time outside of this aperture has been masked, right? There is 0 value, and inside is not masked. Okay, so you can do one more thing, and you can not one thing, you can also, okay, make it right, say here 2. Okay, so see what will happen. So everything beyond this elliptical masking, the value of the pixel is 2. Okay, so this way you can give any number you want, but I will give is 0, and I will put it here 0. So this way you can do elliptical masking, right? You can also make it circular. Okay, so for making circular aperture, so make it here 100 into 100, I mean both are same. So this becomes your circular aperture masking, right? So this way you can do aperture and circular by changing the parameters of your semi major axis A and semi minor axis B. So in this case, circle symmetric, so your theta rotation does not matter. So this way you can do elliptical and circular masking. So I hope you got the idea that how to mask fixed image using circular and elliptical aperture using Photutils. So this is my code. So I have imported Photutils library. I have defined the Alice parameters A, B, and theta. I have a center. Then I have created the aperture. Then I have created a mask. Okay, of the same size as the image. Then I have masked 0 and 1 using inside or outside the elliptical aperture. Then I have plotted the final plot. This is how my results look like. And thank you.